a third example. So this is our third example, which is I call special example. So that I call this special because different types of loading are present in each span. So AI is constant. First, we have to apply the effect of the fixed forces or fixed moments for beams. So those are the expected situation, except for the couple moment, which is we assume always that the moment effect is clockwise. So if after we substitute into the formula, if the result is negative, it means it is counterclockwise. Remember, for the couple load, the effect is different. So we have to assume first that the fixed end moments due to the couple load be clockwise. If after we substitute into the formula, the result is negative, then it is counterclockwise. But for the loadings, these are the effects, rotational effects of the load. So call this FA because it's the left end, FB left, FB right, FC left here, and we have FC right, and of course FB, or you may call it FD left, but if it is the last, then just FD. So fixed moment AB is formula WL square over 12. So W18, L is 8 square over 12, so 96 kilonewton meter. They are equal. Then FA equals FDL also by symmetry. It is 1/2 of 8 times 18. Fixed moment BC on the other hand is by formula P. A is 4, B is 3, so 3 square divided by L square, 7 square, so 18. Then fixed moment CB is you interchange the squared. So 4 squared, then 3. 24.5 times 4 squared times 3 over 7 squared. So you'll get 24 kilonewton meter. Then for fixed moment CD, the formula is MB over L squared, quantity 2L minus 3B, where B is the distance of the couple from D, from the right, so which is 2. So again, MB over L squared, quantity 2L minus 3 times 2. You look at the derivation of this formula here, or recall or memorize this formula. Then the result is positive 24 kilonewton meter, so that means clockwise. So the assumed direction is correct in 4. Then, by the way, if the couple is counterclockwise, you just make it negative. Fixed moment DC, on the other hand, is M, A. A is 3 over L square, quantity 2L minus 3A. So 75 times 3 over 5 square, quantity 2 times 5 minus 3 times 3. So you get positive 9 kilonewton meter. So that's why it's also clockwise as assumed. So those will be the correct directions of fixed moments for span CD. Now for the reactions or nodal forces next. By the way, the reactions will be computed later because the reactions are applied at the supports and the supports do not settle here, so they don't have effect. The supports will not displace vertically. So for B, so this is you treat clockwise positive because these are fixed end forces, and remember nodal forces are opposite to fixed end forces. So the technique is make the clockwise moment positive and counterclockwise negative because you have to change sign. Then whatever is the result, that's the final sign of the nodal force. So it is equal to 96 MBA minus fixed moment BC 18, and the result is positive. So 96 minus 18 is equal to 78. And because the result is positive, it is counterclockwise. Counterclockwise positive, remember. At C, it is fixed moment CD is 24. Then supposedly this is also clockwise, so 24 plus CD 24, so 48. And since the sign is positive, so 24 plus 24 is 48. So that's clockwise. So the nodal force is counterclockwise, so 48 counterclockwise positive. Then lastly for D, the resultation here, because the moment is clockwise, 9 clockwise, so the nodal force should be counterclockwise, so positive 9 also. Or simply 9 plus nothing or minus nothing. So that's 9 counterclockwise. Now that we have found the nodal forces, important nodes are B, C, and D. The important numbers are at D4, at C6. So U4 is theta B, U6 is theta C, and U8 is theta D. So we only need 4, 6, 8. So FA, that's all for FA. Number 4, so 1 half of 8 times 18 because by symmetry, FA equals FBL, so 72. For FBR, we sum up moment about C equals 0. So FBR times 7 plus F fixed moment CB, which is 24, then equals this fixed moment BC, which is equal to 18, then plus the moment of the load 24.5 times 3 about C. So solving for FBR equals 135 over 14 kilonewton. Summation forces Y equals 0 for portion BC. So FCL plus FBR 135 over 14 equals the load 24.5. So FCL is 104 over 7 kilonewtons. Then for portion CR, summation moment at D equals 0. So FCR times 5 plus 24 plus 9 equals 0. So FCR is negative 21.6. So supposedly it's downward, but we just treat it upward, but we have to carry the sign, which is negative 21.6. Summation versus Y, therefore FD is positive 21.6. Because there's no downward load for portion CD, so they must be numerically equal, opposite in signs. So now that we have calculated all this, so as I said, important nodes are 4, 6, and 8. This is the stiffness of member AB, which is 12 over 8 cube, so 3 over 128. Remember that when the span is 8 and you compute 12 over 8 cube, in our previous calculations, there was a span of 8 also before. So to make your solution fast, you just cut and paste that portion where the span is 8 and EI is constant. We will have the same force coefficients in its stiffness for that member. Or if you want to master it, so you compute it one by one. So this is 6 over 8 squared. That's why 3 over 32, the negative of the first. Then you just copy the second. Then same, 3 over 32. This is 4 over 8, so 0.5. This is the negative of this 3 over 32 here. This is 1 half of 0.5, remember? The third row is the negative of the first row elements. And the fourth row is you just copy the second row, then interchange position between the second and the fourth column element. So that's the technique there. Next is KBC, which is 12 over 7 cube. So if you encounter the same cell, you have to cut and paste that value. But if it is your first encounter or your first uh, experience of feeling these cells here, I would suggest that you have to feel them one by one. You just gain experience later to make your solution fast. Then finally, for CD, which is 12 over 5 cube, So we have 12 over 125. This is 6 over 5 squared, so 6 over 25. The negative of 12 over 125. By the way, CD is 5678, 5678. Then copy 6 over 25. Copy 6 over 25 here. This is 4 over 5. 4 over L. 4 EI 1 over L. So 4 over 5. The negative of 6 over 25. Then 1 half of 4 over 5. Then copy the first row with signs change here. Then this is second row except that column position for 2 and 4 interchange. So that's now the complete. Then let's have the tabulation of 4, 6, and 8 only because we are interested of theta B, theta C, and theta D which corresponds to U4, U6, and U8 rather. Then the forces, all these are counterclockwise, so they are all positive, 78, 48, and 9. Then this is 4, 4, 4, 4. We have 0.5 here plus 4 over 7. So 0.5 plus 4 over 7 is 15 over 14. This is 4, 6, 4, 6. There's only one. 4, 6 is 2 over 7. So 6, 4 is also 2 over 7. 2 over 7, 4, 6. 6, 4, 2 over 7. 4, 8, there's no common. 4, 8 here, so 0. So 8, 4 is also 0. This is 6, 6. 6, 6 is, there are two cells common. Negative, positive 4 over 7 plus 4 over 5, 6, 6. 4 over 7 plus 4 over 5 is equal to 48 over 35. Then this is 6, 8, 6, row 6, column 8, 2 fifths. So 2 fifths. So 8, 6 is also 2 fifths. And finally, we have 8, 8. There's only one, and that's 4 fifths. We can now compute U4, U6, U8 by multiplying the inverse of this 3 by 3 matrix with this force matrix here. So U4, U6, U8 is equal to the inverse of this 3 by 3 matrix here multiplied by the global forces matrix. 78, 48, and 9. So solving for the global displacements using your calculator, because that's only 3 by 3, you have 67.27304 over EI for U4, U6 20.72609 over EI, and U8 0.8869565 over EI. So that this corresponds to theta B, theta C, and theta D. For the member forces, member AB first. So we copy the stiffnesses here and we shade first three columns because they are associated with zero displacements. 0, U1, U2, 0, U3 is also 0, only U4 exists, 67.27304. So the fixed forces, we have FA and FBL equal to 72. So 72 and 72 here. For fixed moment here, we have counterclockwise 96. So positive 96 on the other end, BA clockwise, so negative 96. So for the first force, which is RA or shear in AB or A, it is 3 over 32 times 67.27304 plus 72. And you will get 78.307. Then for the second row, moment, AB 0.25 times 67.27304 plus 96, you will get 112.818. For the third, negative 3 over 32 times 67.27304 plus 72, 65.693. And for the fourth, 0.5 times 67.27304 plus negative 96, negative 62.363. Then for member BC, these are the member forces, the specific specification. So suppose this is P3, P4, P5, P6, and just replace them with the proper designation so that you can interpret the results. You can hardly interpret if I put it P3, P4, P5, and P6. So fix and the stiffnesses, force coefficients, we just copy again. Then we have U4 and U6, we'd have displacements 3 and 5, 0 displacements. That's why we shade the column 3 and column 5. Then fix and forces for FBR. FBR is 135 over 14, 135 over 14. Then FC left, FCL 104 over 7 here. Then moment BC, fixed moment BC is equal to 18, so positive 18, while for fixed moment CB, it is 24, but it is clockwise, so negative 24. And to get these values, quantity 6 over 49 times 67.27304 plus 6 over 49 plus 20.72609 plus fixed and force 135 over 14, 20.418. Then for next, 4 over 7 times 67.27304 plus 2 over 7 times quantity 20.72609 plus 1862.363. Next, for shear just to the left of C, negative 6 over 49 times 67.27304 plus quantity negative 6 over 49 times 20.72609 plus 104 over 7, 4.082. And lastly, quantity 2 over 7 times 67.27304 plus 4 over 7 times quantity 20.72609 minus 24 equals 7.604. Then for member CD, fixed and forces, then displacements only at 6 and 8. Then fixed and forces, C left, sorry, C right, FCR is negative 21.6. That's it. Then FD is positive 21.6. Moment CD, fixed and moment CD is 24 clockwise, so that's negative 24 because counterclockwise is positive. Then fixed and moment DC is clockwise, so it's also negative 9. Then to solve for the final member forces, 6 over 25 times 20.72609 plus 6 over 25 times 0.8869565 plus negative 21.6, you get negative 16.413, and so on and so forth, because the calculation of final fixed forces is simply distributing, or we have only matrix multiplication, and that's a basic step. So that's it. That's it. So moment A is negative of 112.818. Moment B is negative 62.363. RB is equal to shear just to the left, which is 65.693, plus shear just to the right, 20.418. So again, 65.693 plus 20.418, you will get 86.111. Then moment B is negative of 62.363, the negative of 62.363. Then R sub C is shear just to the left, 4.082 plus shear just to the right, negative 16.413. So 4.082 plus negative 16.413, you will get negative 12.331. MB is the negative of MBC, negative 62.363. The explanation for this was discussed in examples 1 and 2. So I hope you don't need to question yourselves. M sub C is, because MCD is negative, so you just change the sign. It's positive. Negative means clockwise. And because clockwise is positive at the left for CB, but clockwise moment is positive at the left, then counterclockwise at the right. So because this is negative, it means it's already clockwise. So that's why it's positive 7.064 kilonewton meter. And finally, MD is 0 because there's no moment at the roller end, at the roller end. So that's it.